In the last video, I walked you through the basic structures, the syntax, the data types, the variables in C. Now, during the basic structures, I forgot to inform you on some structures of a typical C program. For instance, in our main function, we have this courier bracelet. Now, this courier bracelet has a corresponding courier bracelet. Inside of these two bracelets is where our code is going to run, or is where we are going to write our expressions or statements. Now, this is the body of our main method. They call this the body. This is the opening tag, and this is the closing tag. Any code written inside the opening tag of main and the closing tag of main is going to run. But if we write codes outside, like functions outside, without including it inside, the function is not going to run. Coming to this variable declaration, I inserted this semicolon. Now, the meaning of this semicolon means termination, meaning it terminates this expression. It tells the compiler that this declaration ends here. Same as this int y declaration. It tells the compiler that this is the end of this statement, as well as this. So, in conclusion, this termination marks shows the end of each expressions. You can see I used it in all expressions that I wrote here. So it tells the compiler that from here to here is one expression, here the second expression, third expression, fourth expression, fifth, and so on. Now you may be thinking about this forward slash that I gave to these write-ups here. Now these are called comments. This is called comments. Now comments allows you to document some parts of your program so that a novice can actually come to your program, read it, and make a meaningful sense of what actually all these expressions are. For example, I wrote in a comment that variable declarations. So I declared the variables. So if anyone comes to read this my code, we actually understand vividly that what I did here was variable declarations. Now moving down, I initialized the variable that I declared here. Now I used the comment initialization, telling anyone reading my codes that this variable that I declared up here are initialized down here. Okay, now this print statement here, if you want to like tell someone, a novice, a typical novice, what it does, the only thing you have to do is just put this forward slash, then write this prints out the message hello world to the screen. If a user sees this, it will inform the person that this prints out an hello world text to the screen. Now this return statement, you can also give it a comment that says this returns 0 upon success and returns 1 upon failure. So with this, anyone reading your code will actually know what each expression does. We have two types of comments. We have the single line comments and we have the multiple line comments. The one that we have used in our program here are called single line comments. Single line comments, you start it with 2 forward slashes, not 1, 2. If you remove 1 slash, you can see it's no more a comment. Okay, so it has to be 2 slashes. Now the multiple comments is being written like this. a forward slash, an asterisk, then the corresponding asterisk, then and the corresponding forward slash. So with this now, you can put so many lines of comments here without having any error. For example, you can see that all of my comments are in about 5 lines. So these are multiple line comments. So you can write a whole bunch of comments here without the compiler flagging it as an error. Now, the compiler ignores anything that is in a comment tag. So when you run this code, the compiler skips the comments. It ignores the comments, but it translates the non-comment expressions or statements. Okay, enough of comments. In the previous video, we saw how to use an integer. In this video, we are going to look at how to use a double, how to declare a double, and how to initialize a double. So I'm using the data type of double and I'm assigning it to xd as the variable name. Now this variable name accepts only double. I create another double, assign it to yd. This memory location called yd accepts only double values. This is how to initialize double variables. So you reference the name double. Remember, we are only referencing the declared variables. We cannot reference undeclared variables because it's going to throw an error. So let's give this variable xd a value. We give it a value of 3.00. Now, this equal sign is called an assignment operator. Now, an assignment operator is used to give a variable a value or to assign a variable a value. For instance, this 3.00 has been assigned to this xd. Why? Because of this equal sign, just one equal sign. This xd now has the value of 3.00. Remember, this equal sign here means assignment operator. It is used to assign a value to a variable. Now let's proceed. yd, let's give it a value of 44.111. These are all valid values. Why is it? Because we are using a data type of double. So these, our variables here, can accept a decimal point values, but integers, these ones that we declared here, can't accept decimal point values. Now let's move forward to floats. But first, let me declare a variable float. Let me comment it so that anyone who reads our code will know what we are trying to do. Now, floats. We are going to declare a variable called xf, and we are going to give it a floating number of 1.3f. Another float variable zf, and we are going to give it 12.5f. Okay, now these are all valid floating point values. So we declared a data type of float, then set it to a variable of xf, then we assign the value of 1.3f. So this signifies float, that is, it has a floating point number. Now we are done with floats. This is how to declare a float, and this is how to okay. Right now we declared a float and we also initialize them instantly. So here in my comment I'm going to say declaration and initialization of floats. So you can declare and also initialize in a single line, or you can declare and initialize on multiple lines. Anyone that you want is all accepted. The compiler knows what it is. So I'm going to use a multiple comment here for this declaration and initialization of floats. So this is a multiple comment. So I'm declaring and also initializing in one line. So having said this, the next one is we are going to print out everything. We are going to run this program so that it's going to print out all these values that we have assigned to our variables. Okay, so stick around. Now we are going to use the function called printf to print our float variables, the double variables, and the integer variables. There are formats in which you can use to print all these numbers. If you are printing an integer, it's not the same way that you print a double numbers or a double variables. But let us take it step by step. Let's go with the integer. Now if you want to print an integer, inside of these brackets you create two inverted comma. For you to be able to print numbers, we have to follow the format or the parameters specified inside of this standard input and output file. Now inside here we put these two inverted commas, then we add our percentage sign. After that we add our D. D is for printing numbers. Now next, what we are going to do here is to put a comma. Now here is where we are going to put our variable. Example x. We want to print only x, this variable x that we gave 12 as the value. So we said that this printf should print the x value that we gave 12. So it's going to print 12 using this format. So this is how to print an integer into your screen. Let's save and run this code. In the next video, I'm going to teach you on how to run your program through the terminal. But right now, you see this gear and green forward arrow here. Just click on it. Okay, you can see that our 12 has been printed. So our x is 12. You can see our x is 12 here, and it's printed out 12 here. So when we now go to the next one, let's give it y. Now y is 13 here. Let's see what it's going to print out for us. You can see it has printed out 13. Now let's give it an error. Let's say we want to print an integer, but we gave it a C. Let's see what is going to happen. Now you can see it didn't print anything. So that means C is not used for integers. Now let's go on to double. We want to print the value of xd, which is 3.00. Now we now go to xd now and change this variable to xd. We save and run. You can see it printed out 3 and it added some extra zeros. Now let's go to our value. Now we wrote here that this xd should have 3.00, but here they added extra 4 zeros. 1 2 3 4. You can see plus these two zeros that we added here. So when printing double, it adds extra zeros. So the total number of zeros, or the total number of digits after the dot sign, will be 6 in numbers. Let's proceed to the next double variable, which is the yd. Now let's copy it and paste in here. Now let's print yd. You can see that it gave us extra 4 zeros. After the dot sign, gave us 1 1, which is what we wrote here. Then after that, it gave us extra 4 zeros. Why? Because it is a double data type. As I said, a double data type only accepts a double value or a double values. Now, for us to avoid all these extra digits that this double is giving us, what we are going to do is you go to your program, you go in between the percentage sign and the F, and in the middle put a dot sign. Then you now specify how many digits do you want after the dot sign. Now I want 3 digits instead of 6. I want 3. Now let's go and let's run our code. Now you can see it gave me 110. Now remember, our yd is 44.11, but specifying it as 3, like we need 3 digits after the dot sign. So that is what it gave us here. This is the dot sign, and these are the 3 digits. Now if we now say we just need 1 digit, let's see what it will give us. Now you can see it removed our initial value, which is the last one, and gave us only the first one. When you want to avoid those zeros, just specify how many digits do you want after the decimal sign. Now the same thing goes with float. Float and double has the same format. For example, I want to print, let me remove this. I want to print the float for this variable, the value of this variable. So you can see we are just referencing the variables, okay, but this number keeps popping out. So that means this variable, these values that we have here has been stored inside of these variables. So whenever we call up this variable, this value will come out. So let us print this variable out by calling this variable. So you can see it's still the same thing with the double. You can see the 6 digits after the dot sign. Now let us now format it so that it will give us what we want. Now we now put dot sign, then we now determine how many digits we want. Now we want only 1 digit, which is this 3. Okay, so we run our code. You can see it gave us 1.3. So guys, that is how to print integers, double and floats. Now the only modification I made in this our code is I included the printing statements, the comments, instructed it to print each of these variables. I went into double and I did the same thing. Gave it comment saying printing double. Now I gave it an expression to print xd for me without specifying what digits to give us or to give me after the dot sign. I specify it should give me only 1 digit after the dot sign. Now I went down here to also include the comments printing floats. I now said it should print the xf and also print the zf. Now this /n means new line. So when it is printing the first integer, it's going to the new line to print the next integer. It's going to the new line to print the z integer. Let's run our codes. Now you can see the first integer, you can see the second integer, you can see the third integer. Now you can see the 2 double and you can see the 2 floats. In the next video, we'll be going in depth on the print functions, the parameters, how to print strings and integers or strings and numbers together.